Hi everyone, welcome to today's tutorial on the LeetCode problem Kim Place Flowers. In this video, we will be diving into a popular coding challenge that tests our ability to solve a problem involving arrays and logical conditions. The Kim Place Flowers problem presents us with a flower bed represented by an array where each element can be either an empty or a planted flower. Our task is to determine if it's possible to plant a given number of new flowers in the flower bed and following the constraint that no adjacent plots can contain flowers. And this problem challenges us to think critically and come up with an efficient algorithm to solve it. And we will start by understanding the problem requirements and the constraints, discussing the intuition behind the solution, and then analyzing the code implementation. I will guide you through each line of code, explaining the syntax, mechanism, algorithm, semantics, and the logic behind the scenes. And before we proceed, make sure to subscribe to this channel and hit the notification bell, and so you won't miss any future tutorials. All right, without further ado, let's get started. The intuition behind this solution is to iterate through the flower bed array and check if there are enough empty adjacent plots to accommodate the required number of new flowers n. And to ensure that we don't violate, the no adjacent flowers rule, we check each plot to see if it is empty 0, and if its adjacent plots are also empty or out of bounds. And if these conditions are met, we can plant a new flower in that plot. And by keeping track of the count of successfully planted flowers, we can determine if we have planted enough flowers to satisfy the requirements. And then if we are able to plant enough flowers, we return true, and indicating that it is possible to plant n new flowers without violating the rules. Otherwise, if we complete the loop without planting enough flowers, we return false. And essentially, this solution leverages the properties of the flower bed array and checks for suitable positions to plant the new flowers, ensuring they are placed without violating the adjacency rule. And now, with that being said, now let's go through the code step by step. First, we define a function called Kim Place Flowers that takes two parameters, two input parameters. Flower bed, which is the array representing the flower bed, and n, which is the number of new flowers to plant. The function will return true if it is possible to plant n new flowers without violating the no adjacent flowers rule, and false otherwise. Then we initialize a variable called count to keep track of the number of new flowers that can be planted. It is initially set to 0. And this line calculates the length of the flower bed array and stores it in the variable length. This length will be used to iterate through the flower bed. And then we start a loop that iterates through each plot in the flower bed array. The loop variable I represents the index of the current plot. And this line checks if the current plot is empty. Current plot is flower bed I is empty, and its adjacent plots are also empty or out of bounds. The conditions ensure that we don't violate the no adjacent flowers rule. If the conditions are met, it means we can plant a new flower in the current plot. And this line updates the value of the current plot to 1, indicating that it has been planted with a flower. By updating the flower bed array in place, we ensure that the no adjacent flowers rule is not violated in subsequent iterations. And this line increments the count variable by 1, indicating that a new flower has been successfully planted. And this line checks if the number of new flowers planted is greater than or equal to the required number of new flowers. If we have planted enough flowers, we can return true, as it is possible to plant n new flowers without violating the rules. And the last line, this line is reached if the condition in the previous line is true. It means we have successfully planted enough flowers, so we return true. While the last line is reached. The last line is reached if the loop completes without being able to plant enough flowers. All right. Okay. Well, the time complexity of this solution is linear. It's the big O of n, right? So where n is the length of the flower bed array. Well, this is because we iterate through each plot in the flower bed array once in the for loop. And the other operations performed within the loop, such as checking conditions and updating variables, have constant time complexity. The space complexity of this solution is the big O of 1, which is constant. We do not use any additional data structures that grow with the input size. The variable, which are count and length, while used in the function, require constant space. The modification is done in place, so no additional space is required. In summary, this solution has a time complexity of big O of n and a space complexity of big O of 1. Right? It has efficient runtime, as it only requires a single pass through the flower bed array, and it does not use any extra memory proportional to the input size. And that concludes our tutorial on the LeetCode problem, Can Place Flowers. Congratulations on making it through the entire video. I hope you found this tutorial helpful and insightful in improving your problem-solving skills. Remember, the key to mastering coding challenges is practice. I encourage you to try solving similar problems on LeetCode and other platforms to reinforce what you have learned in this tutorial. And don't hesitate to explore different variations of this problem to deepen your understanding and become even more proficient. If you found this tutorial helpful, please give it a thumbs up and share it with your fellow programmers. Also, don't forget to subscribe to this channel for more coding tutorials. And if you have any questions, comments, or suggestions for future tutorial topics, please leave them in the comment section below. I value your feedback and would love to hear from you. Thank you for joining me. Happy coding and best of luck with your coding journey. Goodbye.